we've done some pretty amazing things together. It all started when we thought to ourselves, there's gotta be a better way to work with data that makes it easier for developers to create modern applications that scale. Then we got to work. We embraced the document model in version 1.0, built an incredible community platform that's seen hundreds of millions of downloads. Then we went even further, removed operational complexity, launched Atlas in the cloud, then whoosh, your ideas really came to life because your vision plus our innovative data platform became a force to be reckoned with. Together, we moved the world forward, turned keystrokes into key milestones, made apps that change the way we work, eat, live, play, move, and communicate. And our foot's still on the gas. We've integrated search, mobile, and visualization across a multi-cloud platform, helping customers everywhere build their tomorrows. Our technology allows over 35,000 customers globally to set a breakneck pace of innovation across nearly every industry. But we're not done yet, and neither are you, because what lies ahead is even more exciting. It holds more promise, more possibility, more, wow, how'd they think of that? Tomorrow, in other words, is even brighter than today. Tomorrow, we help support newer and more awe-inspiring applications. The applications you haven't dreamed up yet, but will, soon. Just imagine what you'll think of that we can help power. Imagine what you'll invent that we can help you build. Given all we've accomplished so far, just imagine what we'll do tomorrow.
Please welcome to the stage MongoDB Chief Product Officer, Sahir Azam.
Good morning, everyone. Welcome. I'm very excited to be back in Germany. It's been probably 3 or 4 years since I was last here. I love traveling in Europe, and I appreciate you all taking time out of your day to join us. We've got a packed house today. I think there's an overflow upstairs, so really excited to be here. As mentioned, I have the privilege of running the product organization at MongoDB, so I speak with customers like you almost every day around what you're trying to accomplish in your organizations and where you see technology moving forward in your future. I'm excited to walk you through all the different announcements and the work we've been up to over the last couple years since the last time we were here in Germany. I want to start by thanking our premier sponsors, starting with Ionis, Stackit, and SVA. They've been great supporting us throughout this journey over the past few years, along with the other sponsors in the hall behind us. So please stop by and check out what they're doing with MongoDB in the market. Now, we're a very customer-centered company here at MongoDB. And one of the things we heard time in and time out over the previous 3 years is that every organization needed to reorient themselves to a digital-first strategy. Every company, every management team, every board was asking, how quickly can I pivot to interact and deal with my customers digitally when everyone's remote, everyone's locked out of the office? Retailers had to be experts at e-commerce. Gaming and streaming companies had to deal with a surge of demand that they've never seen before. Pharmacies had to deliver medications in new ways to their customers to deal with the global health crisis. And time was of the essence. Speed was critical. And what customers in the world quickly learned is that the fastest way to build applications is with MongoDB. Developers can move extremely fast and ship new capabilities quickly. Product leaders can get to market faster. And executives can seize new opportunities or respond to new threats in the market by leveraging our technology. So why does MongoDB make it so easy to move quickly, to move fast when you're building fast? It all starts with our ethos and focus on developer productivity. So the obvious question is, what's holding developers back? And what we see time in and time out is it's the friction and complexity of working with data. Our founders realized this themselves 15 years ago when they were scaling one of the largest ad platforms in the world, and it still holds true today, many years later. So we've been obsessively focused on removing the friction of working with data for developers building modern applications. And over the past 6 years, I've met with over thousands of customers as Chief Product Officer at MongoDB. They've told me a lot of different things, what they want to see in the product, where they want to see improvements, new products they want us to deliver. But there's one thing I've never heard from a customer. That is, they've never complained about innovating too quickly. Everyone wants to do more. And what we see is that organizations are constantly held back by legacy, expensive, complex tech stacks, which is what's driving the popularity of our technology in the market. And it all fundamentally starts with the core of the platform, the data model itself. There have been many naysayers over the years that have questioned whether a document-oriented database could really be a general-purpose enterprise standard that can drive a variety of mission-critical use cases inside an organization. But developers said something different. In fact, our software has been downloaded over 265 million times worldwide. That means, on average, our software is downloaded 10 times per developer across the globe. And to put this in context, we've seen more downloads in the last year than we have in the previous 12 years of the company's history. Just a massive acceleration of adoption across every geography across the world. Now, in 2016, there was a key inflection point in our company's history. We decided to launch our cloud service, Atlas. Many people thought we were crazy to try to go build a cloud data platform with partners like AWS, Azure, and GCP, especially with their database offerings already in the market. And nobody had really built a meaningful scaled business doing so. But by 2017, 1 year later, we were adding 2,500 users a week. And now, Atlas is used by the majority of our customers. It's the majority of our revenue, and it's the fastest growing part of our business because we see organizations of all sizes adopting and moving to the cloud. And so you're going to hear a lot about Atlas today. At our first conference in 2014, MongoDB had 1,100 customers. We were very proud of that. It was an early company. Asia and a few others here in the crowd were probably around at that time. But today, we're very proud that we have over 37,000 customers leveraging our technology to build amazing applications. They're represented in over 100 countries across the world. And so in order to serve them, we've also grown our organization. We now have 10x more employees than a decade ago in over 30 countries to help serve the global demand for our technology and help customers be successful. And we are very lucky and fortunate to have the who's who of customers globally. We've got organizations such as Boots, a 180-year-old retailer that leverages our technology to define the way they do digital e-commerce in the healthcare business. Toyota, which collects information from their fleet of cars and builds their connected car program on MongoDB. I do wonder if any of these cars out here are dumping data into Atlas somewhere. Q Health, an amazing company that has a home PCR test kit that can get instant results within 20 minutes across the globe, built on MongoDB Atlas and Realm. Vodafone, one of the world's largest technology brands with 140 million IoT devices processing real-time information on their 5G network, built on MongoDB Atlas. So in some way, shape, or form, whether we know it or not, all of us are interacting with MongoDB every single day of our lives. It's backing all of the technology we think about and use. All of this growth has given us immense resources as an organization to continue to invest in innovation and providing more value to you. And in fact, we've invested over $1 billion in R&D cumulatively over the company's history. But we feel like we're just getting started. The world is only going to demand more and more from applications and more from data. In fact, IDC predicts that there will be 750 million new apps built by 2025. That's more applications in the next few years than have been built in the past 40 years of technology history. So an immense scale coming forward in terms of modern new development. And so we're really focused on doubling down and making sure that we keep up and ahead of the market on the demands you have from our technology. In fact, the amount of money we're going to be investing this year in innovation and development and engineering is more than we've invested in the first 10 years of the company's history combined. And we're doing this all for you. Because our mission has always been to empower the innovators, to be able to create, transform, disrupt industries by unleashing the power of software and data. However, many organizations are held back. They're held back by the traditional 40-year-old way of working with data, the traditional relational data model. And if you're a modern company building a global scale application, for example, Foursquare, which does location services for its hundreds of partners worldwide, you just can't build that on a legacy relational technology. It fundamentally does not allow them to move fast enough or scale globally to meet that demand. And so what do organizations do? They take that complexity and wrap it with surrounding technologies, niche technologies to meet a variety of different data use cases, to band-aid and add complexity around that solution. So time in and time out, we see this picture. This is probably a prettier version than what we typically see, where we see a single modern application that has multiple databases, perhaps a relational database, a NoSQL technology, multiple ETL pipelines, 3 streaming technologies, glue and everything else, just to power the modern application requirements. And this sprawl, this complexity, fundamentally slows down innovation. It fundamentally slows down the developers. So we recognize that this approach wouldn't work. The market needs something different. And so a few years ago, we started really thinking about how we could deliver more value and remove this complexity from organizations. And we started building out a platform for innovation, a platform that can empower organizations to move quickly. And we started with 3 key fundamentals. First, we believe that organizations need an elegant developer experience. The days where an executive at the top of a company chooses a technology and pushes it down for all teams to use is over. We have to make sure developers want to use our technology and can build fast and leverage that to build whatever they're thinking. So it all starts with that developer experience. Second, we needed to build capabilities that could support a broad array of workloads, so you don't need 15 niche databases to deal with all the different use cases across your organization. So you could reskill and leverage more scale in your organization over time. And last but certainly not least, it needs to be resilient to be able to power global reach and scale, whether that's availability, performance, and importantly, security. And so we started investing heavily in our cloud platform to go beyond just the database and to deliver a full-on developer data platform, one that starts with a unified interface and a unified query language, supports a broad spectrum of workloads, from transactional use cases to search to analytical processing, all in the same platform. And of course, we do this elastically in the cloud across 100 different regions. Since launching this concept and this platform in June, we've been fortunate to have an immense response from the industry, from press, from analysts, but most importantly, from you, our customers. So, as we get into the talk today, I'm really excited to talk about what's new in our developer data platform and talk about some of the areas and where we're going. So, starting first with the elegant developer experience. In many ways, the story of modern development has been about an increasing levels of abstraction. We moved from physical servers to virtual machines. We moved from virtual machines to containers. And now we're starting to see serverless development really take off. And in fact, we see this architectural model continue to scale. In fact, analysts believe that that's going to be a $40 billion opportunity in market just in the next 3 years. So we're seeing many organizations adopt this modern way of programming. But what we saw in the market over the past few years is that most serverless databases are quite limited. They want to leave developers wanting more. And that starts with a few fundamental problems that we see in the industry. One, most serverless databases are quite limited in functionality. They're basic eventual consistent key value stores in the most popular offerings, or they're a relational database that's been force-fit into a serverless model. Scaling requires a complex trade-off. Either you want to save cost when your application's inactive and try to drive efficiency in the organization, or you have to over-provision the environment and pay for things and pay a cold start tax when a new workload spins up. We often see costs become an unpredictable problem because they grow linearly with the workload. So if you have a gaming application, for example, or a transactional system that has a spike in usage, your costs will actually go through the roof as well. And of course, it creates immense lock-in, whether that's a proprietary cloud environment or in a particular deployment model. Oftentimes we hear customers that want to start developing in serverless, but then move to a dedicated environment to get isolation or scalability characteristics that they can actually control with more granularity. Most technologies don't allow that. And so as we stepped back and said, how can we solve this problem? We focused on building a new model with Atlas Serverless. We launched this in preview last year, and we're super excited to say that it's now generally available for production usage. And with Atlas Serverless, we provide a serverless database without all those compromises. So for one, it has the full power of MongoDB, our expressive query language, strong transactional guarantees, secondary indexing, all of the capabilities you know and love from our technology. It gets rid of the scaling trade-offs. You can scale your compute all the way down to 0 when you're not using the service, but still have the headroom to quickly scale up should a spike come in and traffic start to ramp in your application. We spent a lot of time modeling in to our pricing model usage-based discounts. So as you start to use more and more of the service, you're going to get better efficiency in terms of cost scalability automatically, without pre-provisioned capacity, without any commitments in the basic pricing model. And we give you full deployment and cloud flexibility. You can scale from serverless into a dedicated instance, or you can run on multiple cloud providers, AWS, Azure, or GCP, should your organization ask you to move. Now, Atlas Serverless is a great foundation, but we also wanted to make sure we continue to add more support for varying use cases across an organization. So as we dig into that, I wanted to give a bit of an example. We created a hypothetical application. It's called the Leafy application, staying on brand for MongoDB. And this is a hypothetical marketplace for selling plants. So there's really kind of 3 different users or entities involved in this application. There's sellers. These are people growing plants all over the world that want to go and sell them to consumers all across the globe. And of course, the buyers who want to find that perfect plant for their conference, for their office, for their home. And of course, there's Leafy Corporation itself, the innovative technology company that's built this dual-sided marketplace. So to get started, the buyers of my Leafy Corp application want to easily be able to search and find the plants they need. But oftentimes, creating this human-oriented relevant search experience is quite complicated for most organizations. You typically have your application. You've got your product catalogs and your transactions stored in your operational database. And then you typically need to stand up and run a separate search cluster that can manage that search experience for your application. But that's not all. You typically need to maintain a streaming technology or an ETL pipeline or a data engineering pipeline to integrate the data from your operational data into your search cluster and back and forth. And we hear from organizations that that can actually drag down development by almost 20 to 30% in some scenarios. So 3 years ago, we focused on building something better, and we launched Atlas Search. We built a full Lucene-powered search index automatically inside of the Atlas platform. We launched first with our full-text beta in 2019. And since then, we've been adding more and more capabilities that remove the need to run a dedicated Elastic or a dedicated Solar cluster to power your search use cases. In fact, this is the fastest growing technology in the MongoDB portfolio today. Now, with Search, we've integrated the experience all behind the MongoDB Unified API. So your developers don't need to worry about multiple technologies to learn, multiple drivers, multiple connection strings. It's all one interface, that elegant developer experience I talked about. So a couple key capabilities I want to talk about with Search, starting in 6.0. One is facets. Faceted search is common. Any e-commerce experience you can think of where you've got checkboxes where you want to filter out different goods by the color or the different characteristics of them is all powered by search facets. So we've integrated that natively now into our core platform. And more recently, we just released a capability called More Like This that allows you to define related items, even if they don't have the same text capabilities to define that metadata, making it easier and easier to create rich search experiences in our platform. A great example of a customer that was a fast mover with our search technology is Helvetia. It's one of the largest Swiss insurance companies, and they're serving over 7 million personal and corporate customers across Europe. With their 2025 strategy, they're focused on unlocking innovation for their partners by transforming their core IT systems. And they're doing that by creating something called the Helvetia Container Platform. And as they looked at that platform to drive innovation in their organization, they chose MongoDB Atlas. They migrated from a cloud-native document database into Atlas and moved from Elasticsearch into Atlas Search, combining their infrastructure and allowing them to move 90% faster than having to deal with the operations of multiple systems in their environment. Check out their case study on MongoDB.com. Now, one of the most common ways we all interact with applications is through our mobile phones, our mobile devices, our tablets. And of course, with Leafy, we're going to want our organization to be able to deliver that type of experience to its consumers as well. But unfortunately, creating a rich mobile experience is quite complicated. You typically need some level of local persistence on the device. You need to worry about integrating data to the back end, so you might need a REST API, you need push notification services, you might have a cache or a message queue backing that, and of course you have your core operational database, typically in the cloud. Sounds simple, right? But in fact, it's not. What we see is that mobile teams typically spend a third of their time managing this plumbing, dealing with conflict resolution, trying to build resilient network code, dealing with a variety of edge cases. What if your API sends back data in a format that the client didn't expect? How do you handle that? What if your connection goes to high latency while you're going through a tunnel? All of these scenarios are challenging from a development standpoint to deal with, let alone trying to do that with a protocol that minimizes battery usage and data usage on the device. And so in order to remove this friction and complexity, we bought a company called Realm a few years ago. And what Realm had built was the most popular mobile database in the market. It's open source. You probably have many instances of Realm sitting in your pocket on your mobile phone without ever knowing it. And we loved Realm because it provides that brilliant developer experience that back-end developers have come to love with MongoDB. So we saw a lot of affinity with that technology. And over the last 2 years, we've been working hard with the Realm team, based out of both Copenhagen, New York, and Austin, on building synchronization capabilities that allows you to easily synchronize information from mobile or edge devices back to the cloud. This year, we've enhanced Atlas Device Sync with a few key capabilities. One, the GA of Flexible Sync. This is a much easier way to define queries and policy in role-based access control that can define exactly which data flows down to a particular device based on who's using it and in what conditions you want them to have access to the information. We're also announcing the preview of asymmetric sync. This is for edge use cases where you're collecting write-heavy workloads from a variety of different sensors, perhaps bringing that back to time series collections in MongoDB. And like any development ecosystem, the mobile environment is thriving. So we've implemented new Kotlin and Flutter SDKs to stay abreast of the modern technologies that developers are building on in the mobile community, continuing to invest and stay ahead of the curve. Now, I've gone through how I built my end user experience from a search capability. I talked about how I can empower that on a mobile device or on edge use cases. But what if I want to deliver richer capabilities in my application? In this case, I have a buyer's view. Maybe I want to allow my buyers to have more sophisticated information about their purchases, what the last marketplace price was, the average price that somebody's paid over time. Oftentimes, these experiences are not your standard transactional queries. They're actually analytical queries that are aggregating multiple forms of data, more complicated data sets, and powering that live application experience. That could apply to a buyer, but it could also apply in this case to a seller. Let's say I have a large-scale greenhouse and I'm selling plants all over the globe. I want to be able to understand in real time how much I'm earning, what goods are most popular, where I'm selling them across the globe. Again, complicated analytical queries, but not in the context of dashboards and reports, in the context of the actual application itself. And so for the last few years, we've been figuring out how to make this type of an experience easier. Because what we see is that it typically takes cobbling together of multiple technologies. We see an operational database. Oftentimes, the data processing might happen in an analytical database or a dedicated time series database. And then you need to merge that back perhaps into a cache technology to deliver that at application speed back to your end users at low latency. Again, more complexity, more tools, more technology to stand up and operate in your environment. And so we've been focused on a better way to solve this. And so for years, we've been investing in adding deeper and deeper analytical capabilities into MongoDB with things like window functions. You can do moving averages, for example. New operators such as top and bottom that allow more processing to be pushed down to the database, making your code simpler and easier to manage. And analytical nodes in Atlas, which allows you to tag certain parts of your infrastructure so your analytical queries are not interacting and stomping on your transactional workloads by providing that isolation. Now, we've had thousands of customers in Atlas use analytics nodes, and one of the things we've heard loud and clear, the #1 request that my product team would hear, is the ability to independently scale the analytics infrastructure versus the operational infrastructure, all within a same cluster. So you can start to tune the price performance of analytical queries with dedicated hardware that's distinct and different from the hardware that powers your actual transactions. So you can get better cost efficiency, better performance efficiency, but all still within one operational database that's easy to manage. So beyond just optimizing infrastructure, we also said, what else can we do in the core database to power these in-app analytics experiences? One was improving our join capabilities. We call that $lookup. We've had this in the database for quite some time, but we really ramped up the investment in the last couple years. And we've done that first and foremost by adding sharding support, so you can have joins on large sharded clusters on massive data sets. We've also significantly improved the performance of our lookup engine. So, for example, if you're going and targeting a foreign key index where you're matching a large volume of data, for example, all sales data in my Leafy Corporation application, you can see double the performance. If you're matching a smaller data set of only a few customers, it's your small number of matches, 5 to 10x improvement. And if you're doing analytical exploratory work to understand what's happening in your business, you can see over 100x improvement in our join capabilities with $lookup. So we're really excited to see where this empowers new use cases in your applications. But we also looked out in the market and use cases from our customers and saw that oftentimes they were still standing up dedicated analytics systems with different performance characteristics to power their applications. And this is typical in the market. You have OLTP databases that are optimized around transacting on objects, on records, optimized in a row format. And then you typically have an analytical database that may store information in columnar format, where you're aggregating a single field across multiple records to get faster performance for aggregations. And these are typically different systems. We are now super excited to announce that we are working on column store indexing natively in MongoDB. We keep the same flexible data model on the back end in MongoDB, but we created a new data construct, a new indexing type that allows you to optimize for columnar-oriented aggregations. And we're only scanning in the fields you actually retrieve with your query, so it's super efficient. And of course, since it's MongoDB, we're doing this with all the benefits of documents, arrays, nested objects, and dealing seamlessly with polymorphic data. So we are really excited to see where this takes the performance of in-app analytics and powers modern application development. This can actually drive a 15x improvement in most aggregations and analytical queries that we see. The reason this is important is not just that it reports a dashboard faster, that's not that big of a deal. It's because now you can take queries that previously could only be used for human reporting and decision support, and now embed them in code to drive automated experiences on behalf of your customers. So really moving from downstream analytics to in-app analytics in real time. So if I take a step back to my seller dashboard, I'm managing all the plants that I'm selling worldwide. Oftentimes, these analytical queries and patterns and the underlying data that we see is time series data. You know, for example, this is a time series chart of looking at price history bucketed by month, basically, and all this data goes granularly down to an hour, for example. What we heard from our customers was that they didn't want to stand up a separate time series database, perhaps an InfluxDB or a time stream service, because it added more complexity in their environment. They wanted us to bring that forward into MongoDB natively. And so last year, we announced native time series collections in the database, optimized to handle time series temporal data out of the box. Now, we've been investing heavily in this capability because of the customer demand. And so after our launch, we quickly released sharding support. We added support for online archives, so you could store massive data sets at low cost in the cloud. We added columnar compression, which makes it much more efficient to store this information. Gap filling, so if you have a sensor that falls offline, you're not going to break your queries. It'll automatically fill in that data. And now in 6.0, we've added geo-indexing, rich secondary indexes across the entire time series collection, and significant read performance improvements, continuing to push the ball forward so you don't need dedicated niche technology solutions in your infrastructure. Now, one of our favorite examples and partners in this ecosystem of time series data and IoT workloads is Bosch here in Germany. We've been proud to work with Bosch for over 10 years. They originally started with MongoDB 2.0, so they've been with us on this long journey. And they were an initial design partner for our time series collections. The IoT Insights team from Bosch is actually here, and they will be presenting that 10-year journey and what they've built with their Insights platform later today, so please check out their talk. Now, with all of these different announcements, Atlas has transformed from just an operational system to a unified platform for real-time in-application analytics. Analytical node tiers for optimizing price and performance, faster lookups for better join performance, column store indexing coming to make app speed queries enabled, aggregations enabled in your applications, and of course, time series collections, making it faster and more native to deal with that nuances of that data set. But let's remember that it's not just the developers that are building the seller experience or the developers that are building those buyer dashboards. Leafy Corp, in fact, is an entire company. It takes a lot more than just the development teams and the product teams, for example, to take a business to scale and build a successful organization. And there are many people inside Leafy Corp, like there are in your organization, that need to leverage data inside the organization. You have business analysts that may want to calculate plant sale trends and make reports for the product team, the marketing team, and the executive team. They're data science, who can't do their job at all without data. They're training models and building ways to improve the business constantly and make it more automated. And let's not forget the data engineers, who have to wrangle and integrate all this application and business data to empower those analysts and data scientists inside of an organization. Oftentimes, there are multiple use cases for this type of application data. For example, you might want a historical view of the business. I want to compare my this year performance versus last year performance to see how I'm doing. I may want planning and forecasting out into the future by running trends and analysis with my data science team on this data. But one thing has really been hard on leveraging any operational data for downstream consumers. And that's getting a real-time view of what's happening in the business right now. Earlier, I mentioned that every organization wants to move faster so they can seize new opportunities, reroute goods, optimize their organization in close to real time. But this is extremely complicated to pull off. If you want a real-time view, it requires a ton of complexity to create this type of a dashboard where I can get a real-time visibility into my KPIs and my business. It requires a caching technology, an operational system, just to power the real application experience. You need ETL pipelines managed by data engineers to get those aggregations back up into the caching technology. And of course, you need an enterprise data warehouse. So you need to shift all this data out of your operational systems, reorganize it, just to empower the business intelligence teams and the data scientists to work on that information. It's expensive, it's costly, and the data is lagging and dated. It's not real time. It's often batch oriented. And so we've been thinking about this problem a lot over the last couple years. We've built new technologies in the platform to accomplish this, but I thought the best way to show you what you can do now with the new capabilities is to actually show you a demo. So I want to invite John Page, a long-standing distinguished engineer at MongoDB, one of our most deep technologists, to walk you through some amazing examples. John?
Thank you, Sahir. Hi, I'm actually really excited because I've been asked to come up here and demonstrate to you two quite remarkable new features in Atlas, features that personally got me excited when I saw them. So here's talked about Leafy Corp. And Leafy Corp, as we said, are this global organization who allow people to buy and sell plants, and then have Leafy Corp, the central org, who want to be able to effectively make money out of that by seeing what's going on. Now, the key word in what I just said was international, because when you have an international business like this, it's not oil. Not everybody trades in dollars. People are going to trade in their local currency, which means Leafy Corp have a challenge. They want a real-time view of their business, but that real-time view not only involves them being able to look real-time at all the data sources they have, but also pull in information about current exchange rates to give them an idea of how all of this looks when viewed in a single currency. So I'm going to show you Atlas Data Federation, which allows us to actually go in there and pull multiple data sources together to do this kind of analytics. So to get to Atlas Data Federation, we start on our front screen of Atlas, and you'll see over here in the menu bar on the left-hand side, we have Data Federation. So I'm just going to go in there and set this up and show you how to configure it. I'm very aware that this is probably not how you're going to configure it. We don't configure things through GUIs much, we do configuration as code. And I said, I really want to show configuration as code, but it was pointed out that's not a great demo. So we're going to see it as a GUI, if you'll bear with me. So we go in here, and then I'm going to create a federated database. Now, a federated database is actually a virtual MongoDB instance. So we're going to create like a virtual cluster, a virtual server instance, and we're going to add virtual databases and virtual collections to that. So I'm going to create my virtual instance, and I'm just going to rename it because by default it's called Federated Database Instance 0, and that's going to look terrible on all the photos you take and tweet about this. That's a hint. Okay, so let's call it Leafy Lake, because it's going to contain all our data from our Leafy corporation. I need to look at actually the screen in order to do the demo. And so now I've done that, what I want to do is I want to add a data source to that. Now, we said the first data source that the Leafy Corporation is going to need is access to their live seller data. What are we actually selling right now? So I go in here and I can add a data source. Now this shows me 3 of the data sources I can add. I'm going to choose to add Atlas Cluster in here. I'm going to choose the cluster, and it will show me all of the clusters I have access to. And then it's going to look at those clusters and work out what are the data sources available in them. So here we go. So I'm going to pick that and next. And that pulls all these data sources into this palette on the left. If I had configured an Atlas Data Lake, which is MongoDB's cost-effective system, fully managed cost-effective system for large-scale analytics and data tiering, all of my data lake sources would be in there as well. So I have Data Lake, I have my live clusters there, and what I can do now is I can pull a collection or multiple collections from those live clusters and present them in my virtual database. So I'm just going to rename the virtual database. Let's call it LeafyDB, and then it's hard to type and talk. I'm going to rename my collection to Sellers. And then what I'm going to do is I'm going to drag across the sellers collection from here and drop it here. As I say, this can all be done from code. Now you'll see underneath that, it lets me drop other things. That's because I can create a virtual collection which actually sits on top of multiple data sources, multiple collections, multiple other sources. I can even use wildcards, so as I create new collections with a particular naming pattern, they're automatically added to this virtual view across multiple collections. But I said, this is my live data, but I said Leafy Corp also need to have access to foreign exchange data. So let's create another virtual collection. We'll call that live FX data, FX being foreign exchange rates. And then I'm going to go and add another data source. Now I said already we have Atlas Data Lake, so that's the managed data store. We have our database clusters, but we have 2 other sources here. One is Amazon's S3 object store. So if I have files stored in S3, I have JSON files, I have XML files, I have comma-separated text, or even I have highly compressed Parquet files, those can be pulled in as though they were a MongoDB collection. So we don't need to load that data into Atlas. We can just add those files held in S3 as virtual collections and query across them and analyze and join and do all the things we would do. And that's not even the most exciting thing. Nobody seemed to think S3 was exciting anyway. That's fair enough. We have this one, an HTTP store. Now, if you read the documentation for this, it says you can retrieve files stored on an HTTP server. And my first thought was, well, that's not very exciting. Yeah, who stores their files on HTTP? And then I realized that if we think about something that you give it a URL and it returns you something in a file format, say JSON, that's an API. So what this actually means is that you can attach live external APIs built on other databases by other people to your Atlas cluster as though those were virtual collections and use them through all of the processing. So I'm going to select that, give it a name, live FX rate, and Leafy Corp have subscribed to a service that gives them live, up-to-date foreign exchange rates. So I'm just going to paste that URL in there. You can never remember that key to type it in. And now you'll see I have my data source here, which is an HTTP data source, and I'm going to drop that on here. And finally, save. Now at this point, I've shown you setup, and setup never makes for a super exciting demo. Hopefully I showed you it's easy. Hopefully I reassured you that it can also be done programmatically. What I'm going to show you now is how we go about using that data. Now, if I'm honest, management, marketing, much prefer if I use a nice GUI like Compass or the Data Explorer to do this, but I want to show that this is actually part of the core database capability, and anything that can talk to MongoDB gets access to this. And so I'm going to demonstrate this very old school. I'm going to log into the MongoDB shell and show you it from there. So the MongoDB shell, for those of you that aren't aware, is basically a thin wrapper around one of our drivers. It happens to be the node driver, but it demonstrates that this is part of the core database. I make calls to the database, I get responses back, and any and every tool that talks to MongoDB ultimately uses that same interface to talk to the database. So if I go into the shell and I ask it to show me the collections I've got here, I'm just going to see those two collections that I created, my live FX rate and my seller's view. And I can do a find against the seller's view. And there we go. I see the first record in there. It's a person. It's the foreign currency that they want to use, and it's the things they have for sale. So I did a query. I queried against the federated, the virtual database. It then sent that off to the real MongoDB collection, and it got a response back. Nothing special there. This one, I think, is more interesting. So I'm going to query against the live FX rates database. Remember, there is no database here. This is simply pointing at a back-end API. And I call that, and I get back a response showing me current exchange rates. And what blew my mind when I first saw this is like every time I call that, I actually get a different set of results because exchange rates are constantly changing. 58.93 at the bottom, 59.12 at the bottom. That's a fairly volatile currency. I don't want any money in there. Mind you, what isn't these days? So that's good. The only thing is that that API has responded with data in a particular object format. And whilst MongoDB is a great format for working with objects, I don't particularly like this where it sent me back one object with a field, a member, for every different currency. If I'm going to use that in an analytical process, if I'm going to look up against it, I want it in a more tabular form. Fortunately, one of the things about data federation is it allows me to do a little bit of data engineering on top of that. So I can go into it, hit configure, and then I can create a view on top of that. So I can click here, tell it I want a view, and I'm going to call it like FX table because I'd like it in a tabular form. And then I can use a standard aggregation pipeline. I'll just paste in what I wrote earlier. Not very long, but what that's going to do, and you can always come back and look at the presentation later to see what it actually does, is it's going to transform that object into a more tabular form, one document per price. So then if I go back to my shell, and I now look at the collections, you'll see that I have my original two collections, but I have that view that I just created as well. So I have the FX table view. And that is a view on top of a virtual collection calling an API. I know this is getting a little bit long-winded. And I can query against that as though it were any other collection. So there we go. So currency, there is a currency called Bob. I'm not really sure what that is, but the current rate is 6.89. I'll just do that again. Now it's 6.890. So we can actually do that querying against that virtual collection. So now I have two collections. My live data, which obviously is updating live as people buy and sell things and change their inventories, and also this live virtual against an API collection. So now what I want to do is I want to work out one of those nice dashboards for Leafy Corp. So I'm going to have to run an aggregation pipeline against that. Now, I am briefly going to show you the aggregation pipeline code, but I don't want you to all sit there trying to read it. So what I'm going to do is I'm going to explain to you what the code does, and then you can always come back and read the code later. So just flip to a slide. So basically what we're going to do is we're going to take our seller record here. We're going to grab the currency from that. And we're going to do a dollar lookup on our virtual view table onto our live API to get the current exchange rate. Once we've done that, we're going to write that back inside the pipeline into that record. So it won't actually be written to the record. It will be in the in-memory view of that record. We're then going to divide the price in whatever currency it is by the exchange rate to get a price in dollars. And then we're just going to group all those things together by the plant name to work out how many of each kind of plant are for sale and what the maximum US dollar price, the minimum US dollar price, the average US dollar price is, and so on. So I said I wouldn't show you the code. Actually, I am going to show you the code. The code, where's paste? Code looks like this. And it probably is worth you coming back and having a read of this later and pausing the video. But right now, it's not really worth your time reading the code because the results are going to come up. In fact, too fast for you to take it in. So here, I'm running that, and that is pulling together data from an external API and from MongoDB, putting those two things together and calculating the current quantities, the price, minimum, maximum, and so on for all of those plants. Now, I did notice, a few of you were reading the code there. That's the programmers in the audience. A few other people went, oh, it's code now. That's great, but actually the people that do this in my organization, they don't do MongoDB code, and they don't really want to learn MongoDB code. Is there another way? Well, we've met people who've said, yeah, aggregation, it's not something we really want everybody to learn. And you know what they always ask us? Could you do SQL? Well, we have added Atlas SQL. For those users who are doing a read-only use case, for your analysts, for your back-end Excel warriors, we have added Atlas SQL. And we've added it right down at the lowest level of the database. This isn't some proxy server that sits in between. This isn't something that only talks one protocol. It talks the same protocol that MongoDB itself talks, which means technically any tool, any application that can use MongoDB should be able to use this. What it means is that I can, for instance, create SQL in a string in the Mongo shell. I don't recommend the Mongo shell as a general tool for this. If you're going to use the Mongo shell, use aggregation. But I can create a string in there, and then with a little helper function, I can actually run SQL inside the MongoDB shell for the first time. And I can run SQL inside the MongoDB shell. So what does this mean? What this means is that when you want to use familiar analytic environments, such as Tableau here, now with Atlas Data Federation and Atlas SQL, you can come in and you can use SQL to query against MongoDB, SQL to build those charts, to do analytics. This opens it up to your data scientists. They can be running Jupyter notebooks, and they have a choice of MongoDB query language or SQL. Back office reporting, that person who just likes to make the amazing Excel spreadsheets, they'll be able to use SQL to query against MongoDB. Your business analysts using Tableau or using SAS or using any of those tools. Anything that's integrated with MongoDB, from Kafka pipelines to existing tools that at this point in time have no specific SQL support. If they have support for aggregation, now also have support for SQL. I'm really excited to see how many new use cases and users this opens up MongoDB to. It becomes a Nexus hub for pulling all your data in. And with that, I'd like to invite Sahir back to tell you how you operationalize that. Thanks.
I'm really excited to unveil all these new capabilities that John walked you through, because Atlas is no longer just for developers. It can serve the entire data lifecycle for others in your organization by storing large volumes of data in Atlas Data Lake to efficiently store those and query those for analytical processing. Data federation, as you saw, to combine multiple sources of data into virtual collections. Atlas Charts, which allows you to create dashboards or embed those visualizations natively inside your application experience. And now Atlas SQL, a read-only interface to empower all those analysts and BI teams in your organization to seamlessly integrate with the application data in the platform. Now, our Leafy Corp example here is an amazing application. We've built a successful business end-to-end, but we face the same challenges that all of you face across the world, which is how do we keep our customer data safe? In 2022, we are all stewards of our customers' data. The regulations around privacy, the threats from bad actors are only increasing. Now, the way this is typically managed in a cloud platform is through encryption. Now, encryption shows up in a couple different forms. Oftentimes what you'll see is that there's encryption in transit, so you have your wire protocol encrypted, for example, with TLS, all the way from the users to the client application back to the database, and perhaps even back to the storage infrastructure. And then, of course, you have encryption at rest. So your data that's persisted is actually encrypted on disk, whether that's the cloud provider's keys or integrated into your own key management system. This is kind of brass tacks, table stakes security. Obviously, most data technologies in the industry have this level of encryption out of the box or easily enabled. But this still presents a challenge, because in a cloud environment, you may not be actually operating your database at all. There may be third parties involved, or even inside your own organization, there may be some data that you may not want your DBAs or your operations team to ever access because it's highly sensitive. And the challenge is that when you use these typical technologies, you're still vulnerable because that information is decrypted in memory in the server. And so in 2019, we added capabilities to MongoDB to solve this problem. We added client-side field-level encryption, which means that only the client application can decrypt that information. The server never sees it. The server only sees that encrypted data in memory, separating your cloud providers, your database administrators from the application data itself. It's novel. We've seen a lot of adoption of this, in particular in healthcare, financial services, and government, to be able to move faster to the cloud while still protecting this sensitive data. The problem with this, of course, though, is that by encrypting the database server data information, you severely limit the types of queries you can run. You're limited to very basic point queries. And there's never really been a way to solve this problem around how to encrypt client-side information but still make it accessible for rich processing. But imagine a world in which you can use client-side encryption but still get the expressive query capabilities that your application needs to understand and manipulate the information. True encryption in use. This has never been possible in our industry. 2 years ago, MongoDB acquired a company with academics out of Brown University that were pioneering a new form of technology called structured encryption and applying it to database systems. We brought them into our team and created a new organization focused on building a new technology we called queryable encryption. It's the first step in a major new initiative for MongoDB that will deliver rich, expressive query information while still managing client-side encryption keys, a first in our industry. And our journey here is continuing. So typically what we see is that the way this works is that you may have, for example, social security numbers. This is a German social security example here. That's authenticated with the client and the driver. That gets encrypted from the client before it gets persisted back into the database and turns into an encrypted hash here you can see on the right. Now, the database will actually randomize that. So now you may have the same value, but actually have a different encrypted string stored in the back-end database. So even if somebody had access, they could never trace that that's the same information belonging to the same individual with the same social security number. So that's one level of extra protection. But more importantly, when your application connects, it decrypts that information back to that single value. Without anyone on the server side, whether it's MongoDB employees running Atlas, or whether it's a cloud provider or any other database administrator, ever having access to the key that can decrypt that data. This is super important also for GDPR, because now you can delete a customer's key and know that that information can never be accessed again, no matter what backups have been persisted or downloaded or moved around in an organization or multiple cloud environments. Now, our journey with encryption, I mentioned 2019 with field-level encryption, and now this breakthrough announcement with queryable encryption, it's not over. So we formed our cryptography research group earlier this year. We announced the preview this summer. Today, we can handle equality searches. But going forward in December, we're adding range queries. And then early next year, adding prefix, suffix, and substring queries, all on encrypted data, a first in our industry. To learn more about this magic and how we enabled it, check out our talk later today. There's a dedicated talk on next-gen security for sensitive workloads, all focused on our novel approach with queryable encryption. Now, we're really excited about this because this allows you to leverage extremely sensitive data in the cloud, empower application developers to still build amazing expressive queries on top of that. And of course, this is built on top of a foundation that's open and published. So we test this, we publish it out, we get third-party researchers to validate it. So it's all transparent and open, like any strong security stance should be. Now, I talked through a lot of capabilities in my example of Leafy Corp. I took that initial idea to a global business, selling and transacting plants across the world. But that's great for a new application. It's very easy to sort of innovate and move fast and leverage the best new technology. But what happens if you're in an organization with a lot of legacy data? Oftentimes, your core critical business data to empower those applications is locked up in traditional systems of record on premises. And that's a tough monolithic architecture to try to tease apart. And change is hard. We've been working for years now with organizations that are stuck on their legacy relational databases. The complexity of all those rigid rows and tables, the foreign key relationships, the tricky data models to try to understand, and working with them to try to take that from rows and columns to a natural document format. Because data that's accessed together should be stored together. And it makes things much faster and much more natural for developers to work with. However, we've still seen a lot of challenge. It requires new ways of working with data, new skills in data modeling to make this happen. But there is a benefit in doing so. The organizations that move from legacy systems into Mongo, whether they're offloading a mainframe or tearing down a monolith off Oracle, see a 3 to 5x development increase in terms of velocity and productivity. And oftentimes see savings of over 70% in terms of the price, performance, scalability of their application. But it's hard. It's hard to tease apart that data model, break down the monolith. So we're excited to announce a new capability called Relational Migrator. Relational Migrator inspects your existing relational schema. It connects to your existing databases, analyzes the existing data model. It has a beautiful design interface that allows you to design and map that existing relational model into a document model with all the richness of our polymorphic data model. And it allows you to enable an automatic one-time or continuous C2C migration into the new system. So you can start modernizing your application code piece by piece. We'll be demoing this technology today at the conference. So please check out the talk on Relational Migrator. This is a new capability available in preview. We're working on it with customers, with our solutions architects, our professional services team this year. Our hope is to get this strong enough and proven enough to make this a part of the native Atlas experience in the coming years. If you're interested, please reach out to us. Now, whether it's a new application or a modernization of an existing application into the cloud, scaling an application globally to reach a worldwide audience is something that we know many organizations struggle with. And so we've built capabilities beyond any other cloud data platform. Back in 2016, when we launched Atlas, I almost chuckle when I think about this, we were only in 4 regions in a single cloud provider with our partner AWS. Now today, we are in over 100 regions worldwide across AWS, Azure, and GCP. You can span a single database cluster across multiple cloud providers, mixing and matching these regions as you choose. And recently, we've even expanded. We added new regions in Indonesia, in Chile, in Sweden, and in South Africa. And now, we're not adding 2,500 new users a week, we're adding 25,000 new users a week. So this global scale is empowering worldwide development of new applications across the globe. We're very excited to say that Atlas is the most widely available cloud database service on the planet. Nothing even comes close. So if you want to distribute your data, keep it isolated in regions to serve a worldwide audience, to have low latency performance across the globe, there's no platform that can deliver the reach of Atlas. Now, we're very lucky at MongoDB that we get a lens into the global innovation economy, as we like to talk it about. And just in the last month, I went back to our recent new customers, our new users coming in week over week, and we saw a healthcare company in Norway delivering simulation training for healthcare workers. We saw a new challenger bank out of Vietnam get started that's focused on a digital-only financial experience. A startup out of Chicago who's reimagining dating and social networking. A nonprofit in Mexico who's focused on distributing surplus food from restaurants. And an NGO in South Africa that's crowdsourcing investments for agriculture. This is just a glimpse in the global innovation of what's happening worldwide on this platform. And we are super proud and super excited at MongoDB to work with all of you to understand how you're trying to innovate inside of your organization or build your next new idea and helping you build what comes next. So, thank you for listening to all the new announcements. We have plenty of great talks today. I want to thank our customers, our partners, our employees who put so much work into creating the content for today. So please enjoy the conference. We have many MongoDB employees here to answer questions, and hopefully we can share a beer later this evening. Thanks, everyone.